In this video, I'll give you a hands-on on how to calculate z-test and the bare minimum you should know about calculation of z-test. So this is the formula for z-test. Z-test will be calculated as follows: x bar minus mu and then divide by standard deviation, that is population standard deviation, and then further divide by under root n. So most of you must know this formula. I have already discussed this thing in class. One thing which I would like to bring your attention is this thing is population standard deviation, and this is the big difference between t-test and z-test. So this is population standard deviation. For t-test you use the sample standard deviation. This thing is sample mean, mu is population mean, and n is the sample size. Okay, so let's quickly do one example. So we have this example. Let's read the question. A marketing research firm conducted a survey 10 years ago and found that the average household income of a particular geographic region is 10,000. And this research was done 10 years ago. This is important to remember. Mr. Gupta, who has recently joined the firm as the vice president, has expressed doubts about the accuracy of the data. For verifying the data, the firm has decided to take a random sample of 200 households that yield a sample mean for household income of rupees 11,000, and that is done after 10 years when Gupta has joined the firm. So 10 years back it was 10,000. Now for a small sample of 200 households, they have calculated the mean as 11,000. Now next, assume that the population standard deviation of the household income is rupees 1,200. Verify that Mr. Gupta's doubts using the 7 steps of hypothesis testing. Let's have alpha as 0.05. So the significance level for us will be 5%. So quickly think about the various numbers we should look for to plug in the formula. What formula we have? So our formula will be z is equal to x bar minus mu. So we're looking for sample mean. What is the sample mean? Just have a look at it. So sample mean, let me just show you. So sample mean is 11,000 and population mean is 10,000. This is already given. Most of the cases you have to use some common sense to identify the population mean. It must be some standard which has been already settled. So another thing you need is the population standard deviation, that is 1200 already given, and sample size. Let's plug in all the values and calculate the value of z. So let's plug in these values and calculate. It will be calculated as 11.79. Okay, so basically there are two approaches of doing the z-test. One approach is comparing the calculated z value with the critical value. So first, in this example, I'll be using the critical value approach. Another approach is p-value approach, which I'll discuss after this. So let me just elaborate this question. As it was given that the alpha level you should take alpha level as 0.05. This information is also given, which we have not used in the formula. Another information which we have not used is that whether it's a two-tailed test or it's a one-tailed test. Okay, and this we have had some discussion in the classroom also. I have made one video also for this. You can look at that video also. So right now, because it is not asking us to check whether the sample mean is less than or more than, just asking for whether it is different from the population. So when we are checking, it is just different from the population. It can be either more or less. So we are calculating both the things, either less or more. It means we're testing sample mean is not equal to the population mean. This is our hypothesis. So what is the population mean? in that example. So we have the population mean is 10,000. So first thing we need to do here is to set the hypothesis, set the null hypothesis and the alternate hypothesis, and then set the alpha level. Alpha level is also already given, but what does it indicate? So first let me write the null hypothesis for this question. So null hypothesis will be that your mean is equal to the population mean, which is 10,000. But your alternate hypothesis will be is not equal to 10,000. Why? Because it is a two-tail test. Okay. So how to understand, how to frame your alternate hypothesis? Alternative hypothesis can be framed in three ways, as we already discussed. Either you check mu is less than the population mean, like this one, or you check mu is greater than the population mean, or you check mu is not equal to population mean 10,000. Either of these three conditions you might be checking. So as in this question, it is not asked you should check whether mean has become lesser than 10,000. They have not asked whether mean has become more than 10,000. They just asked whether the mean has changed, the mean income has changed or not. They're asking about just a change. So in our case, we will have a two-tailed hypothesis. Okay, now moving forward, when we have two-tailed hypothesis versus when we have one-tailed hypothesis, how we decide the value of the critical value for corresponding z value, okay, for the z value. So quickly, and how it would look in the diagram. In the normal diagram we see, so we have alpha is given as 0.05. This should be the rejection area. This rejection area on the left and also on the right. Okay, so total probability is 0.05. Here it will be 0.025. Here it will be 0.025. So when we have two-tailed test, whatever is the given significance level, we take alpha by 2 on either side, or both sides. So now when we check the table, we will look for this value, corresponding z value for this level of alpha. We check this thing. Okay, coming back to our question. So here we have given alpha is equal to 0.05. So each side we should have 0.025. Okay, that is, and the value of z for this would be 1.96 plus here and 1.96. So so we have calculated the value of z value as 11.79. So let's compare. So it is obviously greater than 1.96. So the rule of thumb is, if your calculated value z value is greater than the threshold value or the critical value, you will reject the null hypothesis and you will accept the alternate hypothesis. In our case, we will say that the mu is not like mu is equal to 10,000. This is the null hypothesis and we're rejecting it. We're not accepting that the mean is equal to 10,000. We're saying no, mean has been different, mean has changed. And this is like Mr. Gupta. So Mr. Gupta is right in saying that the mean must have been changed. Okay, so and the survey also found that yes, mean has been changed, and whatever hypothesis we have testing, it has rejected the null hypothesis. So we'll have this approach is called as critical value approach, when we compare the calculated z value with the critical z value. And I'll show you some critical z value for some very popular or most used level of significance. Okay, so let me just show you. Okay, so in this table 10.2, you can see If we have alpha is equal to 0.05 and our test is a two-tailed test, so the critical value will be 1.96 as we have recently used. Suppose if we change the value of alpha to 0.1, 10%. So for two-tailed test, it should be 1.645 or less than or more than this. So if our calculated value is more than 1.645 given alpha as 0.10. So we can see as we are changing the alpha, our critical value will change. And these are three incidents for two-tailed region. For example, three incidents. We are changing alpha as 0.10. It is 1.645. Alpha is 0.05. The critical value will be 1.96. Alpha is 0.01. The critical value will be 2.575. So this is one way of testing the hypothesis. And most probably in your case, you will be given critical values, which will be referred as stable values sometimes or critical values. And you may compare your calculated value with the given critical value in the question. In real life, however, when you do analysis in software, so most of the times you will be given both critical values as well as the p-value. The second approach I'll discuss right now. So whenever you calculate the z value corresponding to every z value, you can find out the probability value or p-value. Okay, that we also called as significance. In the previous this example which we had just discussed, so the calculated z value is 11.79. so we can calculate the p-value or significance value for this calculated z value, and then we compare whether it is less than 0.05 or not, because what we want is 0.05 or less than 0.05. So in nutshell, let me just summarize both what we are looking for in both approaches. For critical value approach, when we use critical values, we seek calculated value should be greater than the critical value. Okay, this is using critical value approach. And if we are using p-value approach or significance value approach, we have to check, for example, if we are given 0.05 level, alpha is 0.05. So whatever p value we will calculate should be less than this. So what will be decision making criteria? So the calculated p-value, if we are using a p-value approach, calculated p-value should be less than the given significance level. So whatever level of significance we have set, for example, in our case 0.055%. So calculated value should be less than the level of significance. That's we are looking for in p-value approach.